All right, welcome to lesson 39, simplifying rational expressions. If you're watching this, you should probably already have the notes handout for lesson 39. Just in case you don't already have it, you can find it in Canvas. Go to our module unit 3 learning/lecture materials, and you should see a lot of links there for notes. And one of the links is for lesson 39. There's the PowerPoint, and then there's also the notes answer key. So go find the PowerPoint, print it or follow along, or just follow along here and you'll get the handout next time you're in class. Okay, so in this section, really the next 3 lessons are all about rational expressions. So rational means fractional. So if you have a rational expression, that means you have a fraction. So before we learn about simplifying them, we are going to start by just remembering that sometimes fractions can be undefined. When you divide by 0, your answer is undefined. So these first 3 examples are all about determining what value of x would make the expression not defined, also known as undefined. So the way you answer this question, determine the value or values of the variable for which each expression is not defined. You set the denominator equal to 0. And then you solve that equation, sometimes by factoring if necessary. So number 1 is pretty quick. The denominator just has this factor of x minus 4. So when we set that equal to 0, all we have to do is add 4 to both sides to get the x by itself. So I'm just writing plus 4 on both sides. And then, sorry, it's a little messy here. What we're getting is x equals 4. So 4 would make the denominator 0, right? So if you did 4 minus 4, that's 0. Since 4 would make the denominator 0, 4 makes the expression undefined. So we would say the expression is not defined for x equals 4. So again, all we did was just set the denominator equal to 0. Same thing for number 2 and 3. It's just that these are going to be a little harder because they're going to require factoring. So for number 2, our denominator is x squared plus 7x minus 8. Set that equal to 0. This is a trinomial, 3 terms. We can factor it by setting up our 2 parentheses. This is kind of like FOIL in reverse or trial and error, or guessing and checking, depending on how we learned how to do those. But when you're trinomial, 3 terms, when it starts with x squared, we're going to fill in x for our parentheses at the beginning. And then we're looking for factors that multiply to -8, which is the last term, and then add to +7. So factors of -8 that add to +7, that would be +8 and -1. So we would fill in x plus 8 and x minus 1. Okay, so we have x plus 8, x minus 1. We're going to set each of those equal to 0. My handwriting's getting a little messy, so I'm going to type this right now. So x plus 8 equals 0 for the first factor, and then x minus 1 equals 0. You would solve each of those equations. We're about to get 2 values of x that would make this expression undefined. So for our first equation, x plus 8 equals 0. If you subtract 8 on both sides, you should get x equals -8. So -8 is one of our values that would make the denominator 0 and would make the expression undefined. For x minus 1 equals 0, you would add 1 to both sides and you would get x equals 1. So what this means is our expression is not defined for x equals, and sorry, I'm having trouble fitting my answer in that blank. There we go. For x equals -8 and 1. So when you have more than one value that would make the expression undefined, you can just put a comma in between. You're just listing your answers. So we had 2 answers for this question, 2 values of x that would make the expression undefined. Because when we set the denominator equal to 0, we got 2 factors. We set them each equal to 0. We got x plus 8 equals 0. So that led to -8 as one of our solutions. Then we got x minus 1 equals 0, which led to +1. So the expression is not defined for x equals -8, also for x equals +1. Okay, last one on this slide. The denominator this time is 9x squared minus 25. This is a difference of squares. I'm going to type that. Difference of squares. I'm going to abbreviate here. So that's one of our special factoring formulas. A squared minus b squared equals a plus b. A minus B. Okay, so I'm going to write that pattern here, A plus B, A minus B. So look at our first term of this binomial, two terms. Our first term is 9x squared. What number squared would give us 9x squared? It would be 3x squared. So 3x times 3x gives us 9x squared. What number squared would give us 25? That would be 5. So when we factor this, it's going to be 3x plus 5 times 3x minus 5. So those are our two factors. We're going to set each of those equal to 0, and we'll solve each equation separately. We are going to get fractions for each of these, and that's okay. So when we have 3x plus 5 equals 0, we would subtract 5 on both sides and get 3x equals -5. Then we would divide both sides by 3 and get a fraction, x equals -5 over 3, or -5/3. Similarly, for the other factor, we're going to set it equal to 0. 3x minus 5 equals 0. We would add 5 to both sides and get 3x equals +5. Then we would divide both sides by 3, and we would get x equals +5 over 3. So for this one, our expression is not defined for two different values of x, again, just like the last one, and we can list them with a comma in between. Okay, so I'm going to squeeze that in at the bottom. It's kind of hard to fit it in my little blank here. So the expression is not defined for -5/3, comma, +5/3. Those would be our two distinct answers. There we go. Kind of. Hopefully you can fit it in a little better with your own handwriting. So the expression is not defined for x equals -5/3 or +5/3. And we just put a comma in between as we're listing our two different answers for that question.